conditional expectation and conditional variance. So what is conditional expectation? The expected value of x given that y is a specific small y. That means we care about, on average, what is x given that y is the specific small y. We can actually define a new random variable z that is a function of y that's defined like this. So z is actually a random variable depending on small y. Here is an example. Suppose I have two random variables x and y, where the x is the life expectancy, and then y is the random variable about whether or not have cancer or no cancer, okay? And then these a, b, c, d, e, f are the joint probability between x and y. The point is, if we are now focusing on y is 1, what does it mean? We are talking about what's the expected value of the life expectancy when there's no cancer. So that means what? That means for the information d, e, f has nothing to do with what we care. So in this case, we will ignore d, e, f. So suppose I have this table. With this table, we can get the marginal probability. That means with sum A, B, C, we will get the probability of having no cancer. That means the probability of y is 1. Similarly, if we sum D, E, F, we get the marginal probability y is 2. And lastly, if we sum over the columns, we get the marginal probability of x is 1, x is 2, and x is 3. So now suppose we care about x given that y is 1. What's the life expectancy if there's no cancer? So first, the case y is 2 is related to have cancer. So therefore, this row is useless. So we ignore them and we get this table. This is what? This is basically the summary of if there's no cancer, what are the chances you will have short life, middle life, or long life. And here's an important thing. If we calculate expected value, A, B, C are not probability for this x given y equal 1 because A plus B plus C is not sum to 1. Why? Because this table is a joint probability table. That means what? That means these 6 numbers added together give us 1. A plus B plus C is not necessarily 1. We need to derive from A, B, C to get this new probability. Basically, we just divide everything by the marginal. Now, these 3 terms, they sum to 1. So now we can calculate the expected value. The expected value will be what? The random variable takes the value, multiply the corresponding probability. So we have this multiply this, plus this multiply this, plus this multiply this. So this is the calculation. The important thing is when you perform calculation, make sure what you are dealing with is really a random variable. What's random variable? You have a probability. And probability, you need to fulfill 3 rules. That probability larger than 0 and the sum of all the events has to be 1. In this case, A, B, C are not the probability for this random variable because they do not sum to 1. So you need to do normalization. So here's the example. The same table, and I also get the marginal probability. So now I let z be my random variable that the expected value of x given that y is y. So I have this. So how do I calculate this? So first of all, this is saying that the probability of z has this value given that y is 1. So I need to know what's the chance y is 1, which is this value. And similarly for y is 2, the chance is 0.7. Then how do I compute this guy? I compute this guy by dividing all the number, these are the joint probability, by the marginal probability, and then multiply the corresponding value, which is this expression. So for example, for the first term, it will be 1, that is the x value, multiply the joint, divide by the marginal, that means this is the conditional probability, and then sum over all the other terms. This gives us this number. For y is 2, you do the same thing, okay? Then we get this z random variable. This z random variable say that z have 0.3 chance, we have this value when y is 1, and 0.7 chance, we have this value when y is 2. Then this is just a random variable. How do we get the expected value? We just multiply the z times the probability, we'll get it is 2.1. And now here's a funny thing. So what is this 2.166 thing? This 2.166 thing is basically the expected value of x given that y is 1. So that is this expression. And this 0.3 is the probability that y is 1, which is this. So we have this expression. So EZ is this long expression. And notice that we can actually cancel out all the 0.3. Then we will get this expression. And from here, you see that 1 multiplies 0.05. And here also 1 multiplies 0.25. So I can add them up. What is this 0.05 plus 0.25? It's actually the marginal probability of x equal 1. So what is this? This 1 times the marginal probability of x1, this 2 times the marginal probability of x2, this 3 times the marginal probability of x3 is exactly what? It's exactly EX. So EZ, which is exactly the unconditional expectation. Because EZ, this guy, is this yellow part. And we are taking expected value of the yellow part on y, okay? On y. This will give us EX. Actually, this is called the law of total expected value. And important, this is incorrect. So for example, I have the same table. You may compute as follows. 1 times 0.05 divided by 03 plus 2 times 0.15 divided by 03 plus 3 times 0.1 divided by 03. So what is it? You have this 3 number, divided by 03, get you this. And then on the second line, these 3 terms correspond to this 3 number divided by 07. And you take the sum. And actually this is wrong. So these yellow terms are the blue terms here. These red terms are the red terms here. And they share the same 1, 2, 3, 1, 2, 3. So I can perform factorization, right? Then I get this bracket, I get this bracket, I get this bracket. And then I compute their value. Give me these 3 numbers. Here's the thing. What's expected value? Expected value is the value x multiply the probability px. So if these three brackets are the probability, they should sum to 1. But these three numbers do not sum to 1. They do not represent probability. So therefore, this expression is wrong. Conditional variance. I want to compute the variance of x given that y is y. So first, this is wrong in the same sense as this. Why? Because the bracketed term in the second line, they are not probability. So the suggested approach is to calculate them one by one. The variance of x given that y is y, how many y are there? 1 and 2. So you calculate them case by case. So when y is 1, you ignore the second row, you get the first row. This is the table, right? So again, these three numbers do not sum to 1, they are not probability. So you need to normalize, divide by this. And these three numbers, if you add them up, they sum to 1. So now this is a random variable. You can compute the expected value, 2.16 something. Then what's the variance? Variance is the value minus the expected value, whole thing square, multiply the occurrence probability. Then you compute this. It gives you 0.25. Now, for the case y equal to 2, that means we want a second row. Then we have the second row. First, these three numbers are not probability, so we have to normalize by dividing the numbers by the marginal probability. It gives us these three numbers. Why this is the case? Because now these three numbers, when you add them up, they sum to 1. That means they fulfill the axiom of probability of sample space is 1. Now you have this random variable, you can compute the expected value and also the variance. So this is the way you compute the conditional variance. Now we let W as this expression. So this W is now a random variable and you can compute the expected value and variance again. And you can actually keep going on by calculating the variance of the expected value of a condition and so on. We are not going to do that and it will be a mess. And here are something not in exam. So the expected value of x is the same as the expected value of the conditional expected value. And actually this is called the law of total expectation. You also have the version for the variance that's called the law of total variance, like this. And then the law of total probability, like this. And also the law of total covariance. Together, they form the basis of fundamental theorem of poker.